Yeah, can you guys check if this link is working? I would have there'll be a file called links, and if you go there, you can find all the Tinkercad links for the projects that we're going to be doing today, so that you guys can code along. And yeah, before that, I'll just start off by explaining to you, like before Anish is running a little bit late. So until then, I'll just explain to you the basics of like the coding that we're going to do today. Hmm, 1 second. Yeah, I'll be sharing my screen now. I'll be sharing my screen now. Okay, yeah. As you can see, this is the GitHub link I've created. So when you click that link, you would come to this place, to the link, to this page. The page will come here. So over here, you can click the link start markdown. And over here, as you can see, I've created links Tinkercad projects for each of these. Module 1, module 2, module 3. We'll explain to you what these are throughout the course of the session. So like for now, you just don't need to do anything. Yeah, so before we start today, we'll mostly be using 1 second. Yeah, sorry for that. I'll just go ahead. Yeah, so just go ahead. Yesterday, we're gonna use Tinkercad today because most of you don't have the circuit. So we decided we're gonna show you more circuits and more sensors in Tinkercad. So before we start today, we'll be using we'll just be using code mostly, not code blocks, because code blocks can be used only for a few basic projects. For a majority of sensors, the code block becomes rather more complicated than the normal C++ code. So for now, let me just go ahead and get my Arduino, and yeah, I'll just recap the basic what is this basic LED project just before we start today's session. So the LED, I'll just go ahead, grab my LED, grab a resistor, and connect it to. Wait, I'll just keep it here. And then I'll connect the cathode over here, and then this goes to the ground, and the anode I'll connect it to, say, pin 11. And yeah, as noted earlier yesterday, we should color code the wires. Like the ground is usually black, and the live wire should usually be red. So I'll just keep it that way. And now let's just go into the code. So yesterday we showed you that we can use code blocks for easy coding because it's a very basic circuit. So you can just go ahead, drag this pin, which is an output block, because we need to just output that to blink. So we're just gonna set pin, say 11 to high, and then we want it to blink, right? So we want to blink it. We want it to blink with a time period of 1 second. So high 1 second. So over here, just drag this control block so that it will stay for 1 second, and output LED. Since the LED is connected to pin 11, I'll just go ahead and click that as low, and then I'll wait for another 1 second. As you can see, when you run this circuit, the LED blinks with the correct time period that we want it to. But this is what we showed you yesterday. So today, today we're going to be using mostly the text version, that essentially the code that will be entering into your Arduino. So let me just give you a small comparison side by side before we move ahead with all the complex projects that with a slightly more complex projects that we have in store for you today. So basically, as you can see over here, any Arduino code will have these two blocks. In C++, a block of code represents something that gets executed on its own. So they are usually situated inside two curly braces. These are the curly brackets. So this is called the void setup loop, or this is called the void setup block. So the void setup is essential for every Arduino project. So it essentially what it does is it gets executed only once, and it tells Arduino that what ports we're going to use, or it'll just initialize all the ports that we're going to use, or all the IO peripherals, IO pins that we're going to use. Because over here we're using the pin 11, right? So over here we're just going to type in pin mode 11 output, because we're going to use this pin 11 of the Arduino, digital IO pin 11 of the Arduino, and we're going to be using it as an output pin, because we're going to give it because we're going to control an LED using the pin 11. So the syntax for that is just pin mode remember we told you yesterday that in a code in a general function that has two words, usually the first word is the smaller case and the second word is the uppercase. So over here, over here the pin mode, and in the brackets the arguments should be the first is the pin number that you've connected, the pin number that you're going to be using, and the second one is whether you're going to be using it as an output or an input. And usually in Arduino, all statements except the statements that are declaring the loops or the functions are going to be should end with a semicolon. Now that we've seen what the first loop is all about, let's move on to the void loop. So the void loop is something that gets executed again and again as long as you supply power to the Arduino. As essentially, it's as in the name is pretty self-explanatory. So something that's given inside void loop is what will keep getting executed again and again. That's why you can see that until I stopped the simulation, the LED kept blinking, and the LED kept blinking. So over here, over here we've seen set pin 11 to high, right? So this this statement does exactly what this block did. So digital write 11 comma high. So digital write is a function that you're going to be using to control an output pin. So when you write digital write 11 comma high, it basically sets the pin 11 to high. And delay 1000 is essentially the wait function. So basically, delay, as the name suggests, introduces a delay in the circuit, and the arguments are given in milliseconds. So over here we've given 1, but over here we're giving it 1000 because 1 second is equal to 1000 milliseconds. And the same thing over here, the digital write, we're changing this pin to low, and then we're going to delay it again by 1000. So essentially, this is how the circuit works. And if you want to introduce comments, as you can see, there are some codes that are colored in orange and are followed by a double slash. So if you want to introduce a comment, say I just want to say 1 second. Why can't okay. I cannot change the code over here, so I'll just copy this code and I'll go to the text editor. Yeah, just go to the text. Continue. Okay. So over here, as you can see, if you want a comment is nothing but something that's like an annotation that we've taught that they taught to you yesterday. but for a code. So it doesn't get executed. It is for better understanding for people who are reading the code, right? So suppose I create a circuit, but you might not be able to understand what I've written. So for that, we introduce comments, so that you can easily understand the code. Like over here, they've already commented that wait for 1,000 milliseconds. They've basically said what the statement means. So when you're doing a lot more complex projects, these comments would help people who are third party people who are reading your code to essentially understand what you've done. And yeah, I think that covers the basics of C++. And the code for the blinking LED. I think if Anish is here, we can start.
Yeah, hello everyone.
Yeah.
Okay. Should I share screen or you'll?
I think I'll share the screen for the PPT.
Okay.
Wait, are we audible?
Yeah, you are audible, Sanjay.
Okay, cool. Yeah. Okay, so I'll be sharing my screen.
All right. Welcome to the electronics prototype workshop, day 2. Okay. Hope you all learned yesterday, and now we are more enthusiastic about electronics and Tinkercad and Arduino. Okay. So yesterday I showed you a microcontroller which I used. I said I didn't have Arduino and I am using a different microcontroller. It's called ESP32 actually. And today we'll explore why ESP32, uh, what is ESP32 and why is it better than Arduino. Okay. So ESP32 is nothing but an advanced model of Arduino. It can do all the things which Arduino can do. As well, it has other features as for example, Bluetooth module, Wi-Fi module, etc. So there is something called Internet of Things IoT, in which we connect to internet using wireless communication. Uh, yeah, you know Alexa, right? Alexa, Google Assistant, etc. Yeah, that is basically IoT application. So for projects which requires IoT, we must connect to internet. We need to have a connectivity to internet, but which we cannot do it with the Arduino. So what we do is we'll use ESP32. ESP32 as Wi-Fi module, as I said previously. And yeah, so ESP32 can be used for small projects, like for as a hobbyist, to complex projects, which it is used in industries and for multiple as multiple applications. Yeah, next slide. Yeah, so this is a small history about ESP32. You can go read it. Uh, yeah, the main thing is it is advanced. First of all, it is advanced, as in it has better features than Arduino, and it has Wi-Fi and Bluetooth module. These are the main things which makes ESP32 much better than Arduino. Okay, you might be wondering, yesterday we were praising Arduino a lot, and we were telling we quoted Arduino as the best thing and all, but it's true, as in it's Arduino is used by beginners, and for beginners it serves its purpose very well. And yeah, ESP32 is required only for advanced projects, and Arduino is uh, very well suited for beginner projects. It is much more easier for okay, coming to programming ESP32, like we programmed Arduino yesterday, we have to program ESP32 as well, and we can program it in many environments. It supports many, unlike Arduino, it supports many environments. Here are the few famous environments. The first one is Arduino IDE. Yes, we can use Arduino IDE itself to program ESP32. We have to configure the settings, and yes, we can program it. And there is something called platform IO IDE LUA, and MicroPython is also one of the famous um, platforms which is used for programming. MicroPython is industry standard, and yeah, these are the main platforms where ESP32 can be coded. Yeah, you can see the different the specifications, and you can see that it has high ESP32 has more digital pins, and it has digital pins. Analog pins are also more. It has more SPI and more ports, and the memory is also high, greater than Arduino, and also the operating voltage and current consumption. It shows that low power consumption by ESP32 is lesser than Arduino. And one more point is it is compact and it is smaller than Arduino. And the best point is it is cheaper than Arduino. Even though it is advanced and all, it is cheaper than Arduino. All right, let's get started with today's projects. The first project will be temperature sensor with LCD. The second project will be ultrasonic sensor with servo motor. Third project will be IRTV remote sensor. Yesterday we discussed in the component section about each and every component in brief. Today we'll be dealing it in detail and how they work and how to code them. Yep. Let's start with the first project. Okay, we have divided it into 3 modules. First, we'll introduce to something called LCD. Then we'll introduce to temperature sensor. And third, we'll integrate them both. We'll use them both in a project and create uh, something beautiful. Yep. Okay, first let's start with LCD pin. As you can see on the right side, it has many pins. LCD is, I think you have heard of it, liquid crystal display. Its full form is liquid crystal display. It is used for printing, displaying text. You can find it in many places like swiping machine. On the swiping machine, the LCD screen is there, or on the bus conductors will have, and even phones use LCD displays, and many more. There are many applications. So okay, so there are 16 pins on it. The first pin is VSS or ground. It is connected to the ground pin of, that is the one. It is connected to the ground pin of Arduino, and it is for grounding. The second pin is VCC or the power pin. It is connected to 5-volt pin of Arduino. All right. The rest of okay, the contrast pin. Okay, I'll explain it in Tinkercad itself. Yeah, Sanjeev.
Okay, yeah. I'll switch to Tinkercad.
Yeah.
Oh no, wait. Okay, I'll stop presenting.
Mm. One second, I'll be. Adil, can you give me permission for sharing this screen?
Okay, okay, 1 minute.
Yeah.
Okay, until then, people who are going to be following us with the Tinkercad can just put a yes in the chat.
Yeah, you can follow us in Tinkercad. You can open it first.
A small technical problem. 1 minute.
Yeah, no.
Yeah, I think until then Sanjeev can present or something.
Yeah, Sanjeev,
Yeah.
present the slides once again. We'll show the connections.
Okay. Yeah. Okay. I'll present screen. Okay. Yeah. Do you want to explain this, or I'll
Next slide.
next slide? Huh? Okay.
Yeah, so this is the when you open Tinkercad, we have to assemble the circuit. The circuit looks complicated. As you can see, there are many connections. There is something in between. We'll see that what it is. And yeah, there are many connections, and it's very confusing, right? Yeah,
Yeah.
I'll tell you what we can do now. Yeah, Sanjeev, I think you can
Yeah.
go to the previous slide. I'll
Yeah. Wait.
maybe
Okay.
explain it here itself.
Okay.
Okay, so there is something called after the 5-volt pin, there is something called contrast control, which is connected to a potentiometer. As you can see, as you have seen in the next slide, that thing in between, the blue color thing, that is called a potentiometer. It is nothing but a variable resistance. It can vary the resistance between the two terminals of it. Yep. So the contrast pin is connected to the potentiometer, wiper pin of the potentiometer. So what happens is, contrast, right? It controls the brightness and uh, everything for a display. Uh, so yeah, with the help of varying the potentiometer, varying the resistance, we can change the contrast of the LCD display. Yep, that is contrast pin.
Yeah.
Yeah, and the next pin is register select. The register select, there is something called registers in LCD, and yeah, depending upon the register select, the LCD will know what to do. As in, you can there are two types of commands for LCD. You can either print the data in LCD, display the data in LCD, or we can provide commands like set cursor. Since it is a 16 by 2 LCD, as in there are 2 rows and 16 columns of in the display, and it can represent up it can represent up to 32 characters on an LCD. And
Yeah. So
yeah, and the register
basically,
select pin, with the help of register select pin, you can tell the LCD that which type of command are you using. For example, if you want to print something on LCD, the register select command will be what? Okay, the
yeah.
register select.
So basically, there are two types of registers in an LCD. The problem with this is we thought of explaining all this, but we thought that this would become too technical. So what they've done is, as you can see, there's so many pins on the LCD, right? So we showed you the proper connections for all of the LCDs because we thought that using Arduino, you can only control a device by giving it a high output or low output or a pulse or something like that, right? But but for example, for controlling an LED, then we must know how to convert the data that we want to print into a pulse like this, etc., like setting it to high, low, etc. But using Arduino, that would take a lot of time, and it will take a lot of low-level coding that is not necessary for us, because it would then require us to understand the intricate workings of how an LCD works and what is the circuit inside the LCD, etc. So we were just going to show you what is the connections that we're going to do, and there is something called libraries in Arduino that have already included all of these low-level programming languages as nice little functions like a write, like set cursor or writing. So like basically a print function. So then we could just type in what we want to write and it will print it on the LCD. So for now, what you need to know is there are a lot of pins. There's a register select pin that controls the register of the LCD. There's two types of registers, instruction register and data register. and now there's the read write pin, then there's a bunch of data pins. So you can give the input as 8, so there's 8 data pins, as you can see. So you can give the data as a 4-bit data or an 8-bit data. But for us right now, using a 4-bit data is enough, because
Yeah.
for most of our applications of printing text, 4-bit is enough. And the
Yeah,
last
and
two
the
pins
last
are
two
quite simple.
yeah, last two pins are LED, the backlight LEDs, which the first pin will be connected to +5 volt or the power volt, and the last one will be connected to the ground volt.
Okay. If you can't screen share, then light, I'll do it.
Yeah.
Okay.
Wait, I'll
Like,
check it.
is it working right now, Anish? I think I had made you a
Yeah, I think
co-host.
it's working now.
Okay then. Cool.
Yeah, it's working. Okay. Yeah. I've opened Tinkercad. Create new circuit. All right. So as you have just seen that there are many connections to LCD and there are many wires to set up, and yeah, it's difficult to do all these things. So what Tinkercad has provided is, as we told yesterday, there is something called starters. Uh, yeah, you can use the starters actually. See, this is starter for LED lighting up, etc. There are many starters. So what we can do is we can search for LCD, and you can scroll down and you can find the starter for LCD. Uh, there we go. Oh, okay. Yep. As you can see, once I dragged it out, the circuit is already made. So we need not do any effort. We need not work on it. We just need to add other components, and yeah, and we just need to code it. Uh, yeah, we need not connect all these connections, as everything is already set up by the Arduino by the Tinkercad itself. Okay. Wait. Yeah. Okay. Now let's work on this. Now let's see how to code this. Sanjeev, you will be taking it.
Yeah, I'll take over. Yeah.
Oh shit.
If you could, okay, yeah, I'll explain code here only. Or do I need? Okay, I'll just explain code
Yeah.
here only. Okay. So as you can see, this code, this inbuilt circuit already gives you a code. If you can scroll up a little bit on the code, as you can see, it's a pre-built code. And over here in the circuit, they've commented everything as to what are the pins that we need to connect, etc. And when you come down, yeah, the library, as you can see, there are something's called libraries in C++. Over here, we are using liquidcrystal.h. This is because without using these libraries, as I told before, we must have intricate electrical knowledge as to how the LCD works, what are the pulses or the connections that we need to get in order to get we need to give in order to get our desired output. Right now, that is not our objective. And plus, to make it easier for enthusiasts like us to start coding, considering the fact that Arduino is open source, right? So there are a bunch of enthusiasts before us who came in and who were like, okay, this is very hard. So we'll make it easier by creating a library with a bunch of functions in the library that will allow us to easily control the LCD without much effort. So this library, as you can see, is credit is given there. It was created by David A. Mellis. At this point in time, I would like to I feel like it would be apt for me to give you give you a quote by Sir Isaac Newton. If I have reached if I can see that this far, it is because I'm standing on the shoulder of giants. So what this basically implies is what is implying is that whatever we're learning right now, we're not starting from scratch, right? We're starting from a point that has already reached. That we're starting from a point that has already reached by years and years of research before us. Because if we were starting from scratch, then we would be starting from how to power on a turn off Boolean machine learning. I mean, not machine, the machine language of zeros and ones and binary, right? So I thought we can just take this time to appreciate the work that the engineers and the researchers have done before us, and be thankful for the fact that we don't need to learn all of that. We just need to start off from this high level coding language, and you can go ahead and create cool projects. Yeah, as you can see. This is the Hello World program. We have to print the Hello World. This program is for printing Hello World on the LCD, just like any other programming language. So over here, we're going to go ahead and include the library hash include liquid_crystal.h. The case is very important here. In liquid crystal, the L is capital and the C is capital. So .h signifies that it's a library. And as you can see, the next statement is liquid crystal LCD. So basically, what the statement is doing is that we cannot just start without initializing the LCD or telling the liquid crystal.h that there is an LCD display in our circuit. We cannot go ahead and manipulate it. So what we're essentially doing is we're creating something called an object. The object name over here is given LCD. But it's essentially like a variable name. You can keep it to whatever you like. So over here, they've named the object as LCD, and then on the parenthesis, they've given you the pins where you connect your register select, your register select, your enable pin, and then your data pins. So over here, the register select and the enable pin are connected to the 12th digital output and the 11th digital output respectively. And the 5432 are the 4 data pins that we're going to be using to show the display currently. So now that we've initialized this, we're going to be using the name LCD to access the functions of the LED. So as I've explained before, now let's go into the void setup. The void setup is we're gonna set up the LCD. As I told you, the name of the object or the object is LCD. So if you want to access any function with respect to LCD or in the liquid crystal.h that you need to use LCD to manipulate with, you're supposed to use a period or a dot or a dot between the two functions. So here I'm just so LCD.begin signifies that you're using the begin function for the object LCD. So, and in the brackets we're giving 16,2 because as we stated, there are 16 columns and 2 rows. There can be 16 columns and 2 rows of output in this LCD. And the next one is the simple function that I told you, LCD.print hello world. If we don't have this library, then we must have to code all the data pins individually. But over here, we're saying print hello world for this on this object LCD. So that is so this is the syntax LCD.print on the parenthesis the message you want to give or the variable you want to print. Over here we're giving it in void setup because it's a static message and we don't want it to change through the course of the program. But this LCD.print can be used in void loop as well if you want it to change after each time the loop is running. And next we move on to the void loop that keeps getting executed again and again until the power source is removed. So in the void loop, there is one more, we're introduced to another function called lcd.setCursor. So the lcd.setCursor is what it does is, the name is essentially self-explanatory. The lcd.setCursor, comma 0, comma 1 is you're going to give the column number and the row number. So so basically, as you can see, when I stated that you could ask me what is column 0. So in a computer, we're gonna always start counting from 0. So for example, you have a array or something of you have 10 objects. You're gonna be starting from 0, and then the last object, the 10th object, is gonna be given the number 9. So here the column 1 is given the number 0, and the second row is given the number 1. So you're setting the cursor essentially to the second row and the first column when you're typing down lcd.setCursor. And we can go ahead and remove the last statement because we don't need that for our program today. It is to print the number of milliseconds since reset, but we don't need that. And over here, we don't have any use for lcd.setCursor as well because we're printing the lcd.print in the void setup only. And by default, the cursor when you declare an LCD, the cursor is at 0, 0. And now Anish, maybe you can just print after at 0, 1 you can just print something like welcome to today's session, like as just welcome or something. I put an lcd.print and then to just show them that we can set the cursor to 0, 1 and we can print what we want.
Is blocks available for this code?
No, that is the problem. So for the LCD display, the blocks are not pretty well defined. So that is why we're using code. And this code is available online, so you can just, on Tinkercad only. As you can see, the output is hello world, welcome. Because we have set up the pin at, we've set the set cursor at 0, 1 for the welcome statement. If you have any doubts, you can ask us right now, and if not, we can continue. Yeah, we'll just stay on this site for like a minute or something. And if you guys have any doubts, you can put them in the chat box or something. And or you could, you could just put them in the chat box and you can ask me. Yeah, that component is called ESP32. It is also a microcontroller. Wait, I'll just type it down in the chat. Okay. So the pins in the Arduino, they are not written negative. Wait, by that you mean the
tilde.
You mean the tilde operator, right? So those are basically for the PWM, that is called pulse width modulation. So suppose if you want to give an analog output, these are that pin that Ajal just put on the chat box, that symbol. So those signify that you can give analog output using the digital pin. Because some objects might need a digital pin, and you use this pulse width modulation to to convert digital signals to analog signals. So it's not a negative sign. If you guys have any more doubts, you can put in the chat. Okay, then fine. Then I think we can move on, right?
Yeah. All right. Let me create a new circuit. Okay, now let's move on to temperature sensor. Yeah, as we have discussed yesterday, temperature sensor, nothing but okay, let me pull out my Arduino. Yep. Okay, and we'll search for temperature sensor. Yeah, its name is TMP36. It is nothing but it is used for calculating the temperature. If you have real hardware, if you have a real microcontroller, you can set it up and you can verify your room temperature. You can calculate your room temperature. All right. Okay, so there are 3 terminals. The first terminal, it says power, and we'll be connecting it to the power. Yep, and okay, we'll give it a color to red. And the second pin is ground. Yep, and we'll give it a color black. And the third is about V output. It's the output which it gives the sensor readings is output of the sensor is given, and we'll be connecting it to a analog pin. In this case we are connecting it to A0, you can connect it to any of the pin. What happens is it measures the temperature in a room, and uh, it measures the temperature and sends out the value through the V output to the analog pin. And using this, we have to read out the analog pin. Read the values sent out by the temperature in the analog pin. Yeah, this is the circuit. Now let's start coding it. Sanjeev, you will share the screen.
Yeah, I'll share my screen. Yeah. Yeah, thank you for that, Anish. Yeah, as you can see, I just simulated what Anish did in this circuit. I've already created a circuit and kept it. I'll just change the color to what he did, also green, I suppose. There you go. All right. As you can see, the power is connected to the 5-volt. The ground is connected to the ground pin, and the V out is connected to the A0. Just like, yeah, it's connected to an analog pin because we're going to get an input analog. It's not just going to be high or low because it's the temperature. So it will give you a series of values between 0 and 1023. Yeah, so I'll just go ahead and erase this code because we're going to be coding a new start. Okay, so basically what we need to do now is we need to first figure out what the inputs of the sensor are. This particular sensor can be used between the range of sensitive from -40 degrees to 125 degrees positive. So in this temperature range varies from manufacturer to manufacturer or sensor from sensor, and the input it gives also will vary, like as in the analog input it gives varies for each temperature, and the range of the analog inputs will vary, and it will not give us directly the temperature in centigrade, right? Because the analog inputs can only be from 0 and 10 to 1024 1023. So the negative it will not give. So basically what we need to figure out is we need to figure out a way to convert the analog input it gives into the actual temperature. So I will just go ahead and type over here. I'm just going to create a variable in int or float, say. Okay, I'll just create a variable integer because the value from the temperature sensor is going to be an integer between 0 to 1023. Int temp read is going to be my variable. I'm just going to initialize it to 0. What I did here is I just created a variable called temp read and equaled it to 0. And now that I'm done with that, let me just go ahead into the void setup, and the pin mode I'll just change it because we're not using the 11th pin anymore. We're just going to use the A0, and it's going to be input because we're going to get a input from A0, right? And as I stated earlier, as we showed you yesterday, we're going to use something called for this also, because over here we still don't know what input we're going to get or the range of inputs, right? So for that we need somewhere to display the value of the variable to check what is the value of the variable, and the temperature is low and when the temperature is high. So for that we're going to be using the serial monitor as we explained earlier yesterday. So this is basically just like an output screen in any programming language, and so I'll just show you how to use this. So in the void setup, we need to tell Arduino that we're gonna be using the serial monitor as well in this program. So for that, the code is serial scaps dot begin. Can you please not annotate? Could the host please disable the annotations for the participants? Yeah, I'll be continuing. So the function for initializing the serial monitor is serial.begin scaps and everything else in lowercase, and in the parentheses you're going to give the baud rate or the transmission rate. The default is 9600 or 9600, and that is what we're going to be using. And now let me just go into the void loop. As we've told you that there's something called digital write over here, but this is an analog pin, and we're not going to be writing to it. We're going to be reading from it because because as we've stated earlier, yeah, somebody is able to annotate on my screen. 1 second, I'll try disabling that. Sharing options. Okay, yeah. Yeah, okay. I just disabled annotations for others. All right, I'll just erase this annotation and then we'll get going. We'll just continue with it. Okay, cool. All right. Oh, sorry. I'll just share again. All right. So where were we? All right. So I was going to explain to you about the void loop. So as I was trying to tell you that uh, the analog pin A0 is going to be used as an input pin here, not an output pin. In the LED pin, in the LED program, we used digital write because that is a digital pin and we were outputting a value to it. Over here, it's an input pin. So over here, I mean, most of you might have guessed it. It's very intuitive. The variable is called analog read. So I mean, the function is called analog read. So I'm just going to type temp read is equal to analog read of A0. So what I'm essentially doing here is that I am going to remember I initialized a variable over here called temp read. So I'm calling the variable again and I'm changing its value to the value that this pin has at that time. So I'm reading the value from this pin A0, analog value from this pin A0 and storing it in temp read. Now we want to know what is the value of temp read in we want to find out what the value of temp read is, right? So for that, we want to be printing it on the serial monitor. So over here, there is a the program, I mean, the statement or the syntax for printing a value or a variable onto the serial monitor is serial dot print ln. So you can also put serial dot print, but when you put that, it'll keep printing it horizontally, and we would not want that. Okay, I could just show that to you actually. Temp read. Yep. Okay, so as you can see, okay, so now I'll just be running the code without the, yeah. As you can see, the serial motor gets out of hand really quickly. The value keeps printing horizontally, and we don't want that, and we can't really understand anything from it. So I'm just going to clear the output here, and yeah, so that is why we use another function called serial.print ln, which means every time the function is called, it prints in a new line. We can see how that works over here. All right. So as you can see, each time the value keeps printing on a different line. Now I'll try changing the value for at 25 degrees centigrade. The value of the temp read is 153, and at minus 40, the value of temp read is 20, and at the highest temperature you can measure 125, the value of the temperature is 358. Right. So now what we're doing is, so now that we know what is the lowest value of the temp read variable and what is the highest value of the temp read variable, we want to be able to find out the exact temperature, right? So basically what the analog pin is doing is that from a temperature for a temperature of, okay, I'll just go ahead and type it down here as a comment. So when temp read, the value of variable temp read is equal to 20, then the temperature, actual temperature, I'll just write it as temp, is equal to minus 40, right? And the next statement is when temp read is equal to say 358 at the highest value, the temperature measured by the external temperature is 125. So as you can see, these signify 2 points in a straight line, right? So if we just figure out the equation of the straight line, we can just find out. So basically, when you plot the temperature at the y-axis and the temp read at the x-axis, so for each value of temp read, you can get the value of temperature. You can get the value of the temperature in the room. So you could so for that you could just find out the equation of the line. I'll just show you that. I'll just show you the equation of the line right now. Say
So what is the function of serial begin? Serial dot begin.
Yeah, okay. So serial.begin is essentially a function that that initializes the serial monitor, right? Also, we're using the serial monitor here to check the value of the variable, right, for the project to work. So the serial.begin function initializes the serial monitor. So inside void setup, so void setup, as I told you, this is the loop where you set up the components, you let Arduino know what components you're going to be using. So over here, serial.begin is what we use to set up the serial monitor. Hope your doubt was clear.
Okay, sir.
All right. So now moving on. Yeah. So these two. So as I was stating, these were the two straight lines. I mean, to find out the equation of straight line, I'll just type it down for you here. You can go ahead and check it later on. You can use the slope method, etc. So temp is equal to temp read minus 20, the lowest value of the temp read variable, into 165. That is the I'll explain it to you later. 165 divided by 338 and minus 40. Right. So this would be the equation of the straight line. So let me just show you that so this is the straight line, and let me just show you that this equation works. So I'll just go ahead and initialize another variable called float temp equal to 0, and yes, I'll just go ahead and copy this code and I'll paste it over here. And yeah, semicolon is important, and then I'll print the temperature of the room to show you how it works. Wait, what is the other? Okay, I might have forgotten a semicolon somewhere. Okay, just a second.
There is an extra bracket, I guess. No, open.
Open, close, close, close. Okay, wait. Well, let me just type this down again. I'll make it int for now, and if we come into any other trouble, we'll figure it out later. And so temp is equal to temp read minus 20 into 165 by 338 minus 40 semicolon. Okay, so this should work. All right. So as you can see, the serial monitor, it's outputting in the near almost close. So for 25, we're getting a 20. That is because of the variables that because not all values can be integers. As you can see, for negative 40, we're getting negative 40. For around for 82, we're getting 82, etc. So this equation works, but as you can see, this equation is not very easy to come up with. You need some time, like off computer. You need to look at the 2 points, and you need to come up with the equation. So for that, Arduino has given us a very easy code, easy function called map. So essentially, what we're going to be doing is map. I'll just remove the parentheses. So this is an inbuilt function in Arduino. What it does is it is going to map. Okay, I'll just type down the syntax and I'll explain it to you. Template, 20, 358, negative 40, 125. All right. So okay, I'll just show it to you that this works the same way. Yep, as you can see, you get the same outputs there and there and there and there. So this can easily be used to. So now we're getting a desired output that is displaying the temperature on the screen. And yeah, so now what we're doing is I'll just explain this code. What we're doing here is this code. This statement is essentially similar to this statement, except over here you can use any. So you just I'll tell you what it means. So map, the first argument is the variable that you're going to map. And so these, so 20 and 358 over here, you have to give the second argument is the lowest value the variable can take. As we have seen for minus 40 degrees, you get a 20, and for 125, this is the maximum value the variable can take, that is 358. And the next is the range you want to plot it from. So basically, I want to plot, I'm telling it that temp read can take a value from 20 to 358. And corresponding to that, I want a value from the range minus 40 to 125. So that is essentially what this map function does. Now that we're done with this program, let us move on to our next one. So let me just go and show you the slides. So this is the first program that we did, just showing what an LEDs and how it works, LCDs and how it works. Just present it. There, you can find the code on the GitHub, that this link on the GitHub that I shared to you. Next, and then next I've showed you the connections of the LCD. Yeah, and I also explained to you why I would not. This is a meme from Avengers Endgame, if any of you recognize. I just put in this meme because, as I explained to you, these connections are quite complex and they require a lot of low-level programming to understand. And yeah, the next, and this is the 1B using the only temperature sensor. We just did it, and you can find the code over there. And this is the final project that we'll be doing using both. Anish, do you want to take up the circuit attachment, or I'll just do it?
Yeah, you can do it.
Yeah, okay.
Yeah, previous.
All right. So over here, wait, what did we just do now? Yes, this is the program. This is the code that we've done all, as far, so far. And I'll just go ahead and, okay, yeah, before that, do any of you have doubts? I'll just leave this code set for a while, and if you guys have some doubts, you can just ask me. Yeah, the equation I've given over here about void setup as a comment, that equation should work. Let me just check the equation once again. And you guys can figure out how the equation comes, where it comes, basically by plotting these two lines, or you guys can figure out finding the equation of a straight line when you're given 2 points on it, right? So just try that, you'll get it. Okay. If you guys have any more doubts, you can ask me. Say not. Yeah, it's A not, it's A0, not AO. Azim, you have instead of A, like in the pin mode, in your setting up inside the void setup, the first statement, it's pin mode A not AO. A0. Yeah, A0. And the rest of your code. Oh yeah, okay. And the temp read also. Inside the void loop, the first statement, put A0 instead of A not. I mean put A0 instead of AO. And other than that, I think your code seems fine. Yep, just try that and it should work.
Yeah.
All right. Okay, yeah. So now let's just move on to the 1C, the final project. That is, yep, that is combining the two things that we just learned. And I'll just go ahead and create a new circuit. All right, create new circuit. Okay, just give me a minute. Just give me a second. I'll just have some water. All right. Now let us begin. So first program we introduce you to the LCD display. So and the second program we introduce you to the temperature sensor. Now let's see how we can use both of them together. All right. Let me just go ahead and get the LCD starter kit there. Also, if you are at home and trying this out, then remember that you need to connect all of these components in the way given by this circuit. All right, now that the LCD pin is ready, LCD is ready. I'll just go ahead and get my temperature sensor. I'll just drop it anywhere actually. That doesn't like just drop it anywhere that doesn't intersect with your LCD display. And yeah, I'll just go ahead and connect this to the power pin to the power. Yep, that is on of the that is red in color, the ground pin to the ground. And I'll just go ahead and take this output pin and connect it to A0. That's it. There you go. Done. And let's just change the color to green. Okay. So now our circuit is ready and we can start coding. As you can see, this is the code for hello world program. Let's keep it there because it is initializing. And let's just remove the print line because we are going to print the temperature. So instead of hello world, we wanted to print temperature and on the first line. That is cool. CD.print, here. And let us go ahead and initialize our analog pin. Pin mode A0, just basically what we did in our last code because the temperature sensor is connected to A0, comma input, because we're going to take the input from the pin. Done. Pin mode A0, comma input. And then we will not be requiring the serial monitor in this one. So if we do, we can just come back again and change the codes that we needed. And yeah, we don't want this, so we just remove this. And now let me just declare the two variables int temporary that we used equals 0 in temp equals 0. Now let's just go ahead and initialize temp read. We're going to get the value of the temperature input value from the pin A0 equals analog read of A0. And let's just go ahead and map it. Temp equals map of temp read. We want to map temp read. We know the range already because we're using the same sensor from 20 to 358 to, and from minus 40 to 125. And we want we set the cursor at the second column first column, second row, and we're going to be printing the temperature. So that is LCD dot print of temp. This should work. Yes. As you can see, here the value is changing. Okay, wait, as you can see, the value is not exact because the mapping might not be exact because we're using int variables. But okay, wait.
Sanjeev, in map you made it 135.
Oh, okay. All right. Now, as you can see, it's working. What is this? Why is it showing 100? Okay, so there is a problem with the map function in between.
No, we have to clear LCD. LCD dot clear screen. LCD dot clear.
Okay, so I'll just put it over here. LCD.clear, right?
Yeah.
All right.
Oh
Okay,
shit.
okay, okay.
I think it should be placed.
I think we should give some delay too, right?
No, no,
Wait, there's LCD.clear screen, right?
no. LCD not clear itself, not screen.
Okay.
Yeah, you could give a delay and
All right. Yeah, makes sense. What is wrong with? Okay, there's something wrong with the simulator. It's okay. Yeah, wait. I'll just reopen the simulator. I'll just copy my code. I'll go to Tinkercad. There's something wrong with that circuit.
no. You clicked on 3D.
Oh damn. Okay. I'll just go to circuits. Create new circuit. Pick the LCD. Go ahead, get my temperature sensor. Drop it here. Connect the power to the power pin. Make it red. Connect the ground to the ground pin. Make it black. Oh, no. Hit the screen. There you go. Now I'll just copy paste the code. I'll just paste the code. Just delete everything. Yep. Let me just check if the code is right once. Then I'll hit run. Yes, LCD dot clear.
Uh,
All right.
you can give a
Alright.
delay at the end, I guess.
Yes, I've just added in there.
Yeah, and LCD not clear. There should be.
I'll put the temperature as well in here
Yeah.
because we're going to be clearing that. So just LCD dot clear.
Sir, move LCD dot clear to void setup. Then it's work.
Oh, okay. Yeah, as you can see, this also works when you introduce a delay. Then, like after every time, you can clear it because when you change the value, I'll just move the socket. That, as you can see, the value is changing and it's working fine. For 28, it's showing 28 minus 28. Negative 40, you're getting negative 40. And yes, for negative 10 is negative 10. So now we can, so now that we've reached the end of this project, now we've learned how to use the LCD display. We've learned how to find the range of the temperature sensor, and we've learned how to print the temperature that we've received on the LCD display. If you guys have any doubts, you guys can ask.
Yeah, as if I assume you mean the data bits on the LCD screen. There are 8 pins, DB 0 to 7, not 9. There are 8 pins, and there we can use all the bits, or we can use only the 4 bits. 4 bits serves the purpose for us. There are 2 modes. We can use the 4-bit mode and it serves the purpose very well. We don't need to use the other 4 bits.
Yeah. Plus, why we use smaller, lesser number of bits is because when you use more bits, they will take up more I/O ports in the Arduino, and that will reduce the ability of you to connect more components to the Arduino Uno and try out more projects. So the 4-bit should work good enough for all our basic projects. If any of you have any more doubts, I'll just leave this circuit set here for a while. If you have doubts, you can ask.
Yeah, people who tried and it's working, you can put a yes in the chat. Nice.
All right. So, okay. So then, Anish, we'll move on to the next one.
Yeah, 1 more minute and we'll move on.
Okay. Yeah. Let's just wait for one more.
Sir, can you show one more? That's
One more. Oh, you want to run the code once more?
Not the simulation.
All right. As you can see, when I'm changing the value of the temperature to 20 to say minus 19, it is showing minus 20. That is because of in the map function, we've declared temp as an integer. So you might have a plus minus 1 difference, but most of the time it should work fine. Say, for example, here 23, it works as 23. And yeah, negative 40, negative 40. Yep. All right. Okay. I think. Okay, cool. Next, we'll move on. So now we've reached the end of the module 1. You can find the circuits over here in this. I've put it as 1A, 1B, 1C. And now let's move on to the second module. All right, I'll present the screen. So the second module, we've split it into 3 sub-projects again, because we're going to be introducing 2 new components, and we thought let's introduce them one by one, and then let's go ahead with the combined project. So let's just move ahead to project 2A. So this is basically what a servo motor looks like in real life. It has 3 pins. The VCC, the ground. The VCC is what you connect to the 5-volt pin or the signal pin, and the ground is what you connect to the ground of the Arduino. And this servo motors are basically motor. See, we need so far the only output device we've showed you is the LCD and the LED. So, but to show you that the Arduino can actually perform physical tasks, we're going to introduce the servo motor. So you can connect if you connect more powerful motors, you can you can move powerful things, but this motor can. Servo motors are devices that have a great accuracy. They can print. They have a servo arm which can turn from 0 degrees to um, that can be used as from 0 degrees to 10 degrees. And yes, for this circuit, Ani should be taking over in his computer.
I guess you can tell the schematics, but I'll go over this
all,
board.
all right. Okay. So I'll just show you the servo motor and its schematics. Open a new, create new circuit. Okay. For this, I'll just go ahead and type in Arduino. I'll get my board. For this, we don't need a breadboard because the circuit is very simple. And I'll just go ahead and search servo motor. There you go. Bring out the motor that says
This
micro
is
servo.
Tata's servo project.
Yeah, but we know that, but we're just teaching you the basic connections. We're going from basics here, right? Plus the servo motor is very simple only. So over here we'll just connect the ground to the ground. Ground, perfect. I'll change it to black. Signal pin to 5 volt. I'll change this to color red. And I'll just connect this to say pin 9.
Sanjeev, power pin, you have connected power pin to 9.
Oh damn, okay. Sorry. And yes, sorry for that. This is the power pin. Yep. And this is the signal pin, as you can see. Go ahead and connect it to say number 9. I'll change the color to green. All right. For this, as you guys asked, there is already okay. Anish, if you would like to explain the circuit, I mean the code.
Yeah,
Okay, do I stop sharing or?
yeah, you can stop.
Okay, cool.
Yeah, as you can see, I've connected it already. Yeah, and one more point in the schematics is the signal pin, you have to connect it to, you cannot connect it to any pin in the digital pin. You have to connect it to a, am I audible? Yeah, you can connect it only to a PWM pin.
Yes.
To pin number 3 or 5 or 6 or 9 or 10 or 11. You can connect it only to the PWM pins for the servo motor, or else it will not work. Yeah, let's do the coding. Okay, as you can see, it's already coded. We'll be coding from scratch once again. Yeah, a servo motor can be coded on the code blocks, and it is simple and it is straightforward. You have to pull this bubble out and connect it to pin 9, and yeah, the code is out. But we'll yeah, do start from scratch, as you all know coding now, as we have explained the coding little bit. Okay, all right. So first, what we are doing is including server.h. This is the library for servo motor, as we just discovered about the library of LCD. There is a library for servo motor as well, and yeah, it is called server.h. And Then from this library, we are creating a object so that we can use the functions present inside the library. Here the name is servo_9. uh, it, it's because of the code blocks the name, but you can put it anything. You can put it as my server, as server1, or anything. Okay, let's go with server1. Yeah, and in the void setup you have to start like in the previous case we are doing serial begin, and yeah, instead of begin, and for servo motor you have to use something called attach, servo attach. And yeah, this is the pin number which to which it is connected to, and here it is 9. And yeah, these are the minimum and maximum values of the pin, which we need not go into. Actually, this is optional. You can just erase it off. All right. Yeah, we have to rename it because we have renamed it. No. So what happens? Now we are using write command, and servo1 dot write and 90. What this does is it rotates the servo arm by 90 degrees. We are writing it 90, so it rotates the servo arm by 90 degrees. Let's start the simulation and check if it's working. Yep, as you can see, it got rotated to, by 90 degrees. Yeah, this is the servo motor, and it has many applications. It can be used to control many things, and yeah, we'll be doing a project as well on this.
Yeah, do you want to share the PPT, or do I go ahead and share the PPT?
Okay, I'll share it.
All right, as we've told you that for this project, we're going to be using two new components: the servo motor and the ultrasonic sensor. Uh, as we showed you how the servo motor works, using the servo.h library, creating a servo object, changing it. Yeah, and also something that Anish mentioned is that we need to connect the signal only to a PWM pin. That is because the input to it is not just high or low. It should give you a pulse that it should give a pulse that should tell it to go to. Basically, should give an analog output that tells it to go to any angle between 0 and 180. Yeah, next slide. For this, so the next project, we're going to be introducing the ultrasonic sensor. So basically, what the ultrasonic sensor is that I assume that all of you have read the chapter, must have read the chapter. Okay, Hania is asking how to make the circuit again. Yes, we will be showing it to you the third project anyway, because we have to do this. So just hang on for a second, I guess. So the ultrasonic sensor is basically used to measure the distance from an object. So what it does is, I assume you guys have read about the sound and waves chapter. In that chapter, you would have read about the section of sonar that is used to detect the distance of that is used to calculate the distance from an obstacle, using the amount of time using a transmitter to send a signal and calculating the amount of time the signal takes to bounce back. That is essentially the same principle that we're going to be using here. As you can see in the picture, there are these two boombox kind of thingies. One side it's marked T and the other side is marked an R. So the T means that's the transmitter and the R is the receiver. Yeah. Next slide. Yeah, as you can see, this is how it calculates. So the trigger pin sends out a signal, and the receiver receives a signal, and using the time period it takes, we will be calculating the distance. And I think Anish will be taking up the coding.
Yeah. Okay. All right. We'll create a new circuit. Okay. let's pull out our Arduino. And then we'll use something called ultrasonic sensor, ultrasonic distance sensor. We'll be using HC's SR04. All right. Okay. Now we'll
As you can see, oh yeah, I'll just explain the pins. As you can see, there are 4 pins. One is the VCC that we connect to the high pin, that the 5 volt of the Arduino, the ground pin that is connected to uh, the ground of the Arduino, and there are 2 other pins, the trigger and the echo pin that are used to send a signal and find out the time.
okay. Yeah. So the first pin is power. Let's connect to the power. Yeah. The last pin is ground. Let's connect it to the ground. All right. And these 2 pins, you can connect it to any of the digital pins present here. All right. Okay. I chose 7. You can choose anything. Okay, it's confusing. All right. Yeah. So this is it. This is the connections, and now we need to start the coding. Uh, no, you can connect to any of the pins. Only for servo motor, we have to use PWM. Uh, for uh, for ultrasonic distance sensor, we need not use PWM. All right, let's code it. We can remove this part. Wait a second, my mouse is troubling. All right, first okay, we'll define 2 integer variables in trig as 6, as we have connected it to 6, and in echo is equal to 7. Yeah. Now as we have seen in the slide, the trig from the trig, there is a wave pulse which is passing out, so it is output, and pin mode echo, this is the input pin, and from this we read the data. All right. Yeah, so first we write, let me write it down. Yeah, so first we write the digital pin trig of the trig to 0, and then we'll give a small delay of 2 milliseconds probably, and then we'll write the pin now, trig to 1. So now initially the pulse was 0. Now it rose to 1. It was 0, it rose to 1, and we'll keep it as 1 for 20 microseconds, and then we'll bring it back to 0. So in this process, what we have done is we have created a very short pulse which ranges only for 20 microseconds, and yeah, that hits the object and returns to the sensor, which is collected by the which the readings are collected by the echo pin. All right, now we'll also define two variables, double duration as well as distance. Okay, so what the ultrasonic sensor finds is, it finds out the time it takes to travel but to travel the wave to hit back. The trick function emits a wave, and it hits an object and comes back to the sensor, and the time is what it calculates, and will calculate it and will store it in the uh, variable duration using a function called pulse in and pulse in echo. Yeah. So now the variable duration as the readings of echo, and it now basically tells how much time it took to reach for the signal to hit the object and come back. Now using that, we'll find the distance. As you know, the formula distance equal to speed into time. We know the time now, and for the distance we already calculated it. Okay, so this is 29.1. It is the reciprocal of the speed of sound. Speed of the sound, as you all know, it is around 340 to 330 to 340, and the reciprocal is 29.1. We have already calculated it, and yeah, it is in centimeter, the exact units which needs to be in. And also we need to divide it by 2 because shit. Yeah, because the wave is traveling and then coming back. It's a to and fro motion. So we have to divide it by 2. Yeah, Sanjeev, is the number right? 29.1.
Yeah, 1 second. Let me just check it. I think it should be right. And yeah, it is 29.1, right?
Yeah. And now, all right, we'll also we'll print the values in the serial monitor. So we'll have to begin the serial monitor. 9600, and then we'll print it in the serial monitor. Serial dot print ln distance. Yeah, and that this 29.1 is for value in centimeters, and let's see how it works, if it works. All right. Okay, the pulse in has other parameters as well. Okay, just give me a second.
Yeah, pulse and echo, comma 1.
Okay, we have to, yeah, there is some other parameter as well. I think this is to raise it to 1, I guess, to give the digital output. I mean,
Yeah, exactly. Yeah, it is to raise the digital output to 1. So you're raising the pin number to 1. Like you're giving the pin number, right? Echo pin.
Yeah, we have to for reading from it, we have to raise it to 1, and then using the pulse in, we'll store it in duration. Now let's see if it works. As you can see, it is approximate again. It is 63.7 and it is printing around 63. It is approximate, but it is good enough.
Yeah, for most real life use cases, this is good enough. If you want to make it more accurate, you could try playing around with the conversion factor that we use to convert the distance to centimeters, and you can try around like using this, or you can just because the value of the speed of of ultrasonic waves, you need to put it in exactly in your location. It might change. So these inaccuracies in the value in the measurement will happen, but for most of our practical use cases, we can work with this.
Yep. This 29.1, yeah, it is approximate again. So if you change it to proper value, you can make it preciser. Yeah, and this is how ultrasonic sensor works. Ultrasonic distance.
Yeah, I think we can wait for a few minutes, right? So
Yep.
that like they can look at the code.
Yeah, you can ask the doubts in the chat.
Yeah, can you just show the code? People are asking you to show the
Oh,
code.
yeah, sorry. Yeah, as I said, 29.1 is calculated depending on the units and also
The units and the speed of sound.
the speed of the
right?
sound.
So basically, the mathematical equation for creating this is, for example, if the time taken to go and come is t, then t by 2 will be the time taken for sound to travel from one end to the to where the obstacle is going, and then you can just use the value of the speed to divide it, and then you can get the distance, right? Because distance by time, it should be equal to the speed of sound. So you can take a rough value of the sound, and you can get a conversion factor, and you can use it in your code as well. I think the speed of sound should approximately be 330 meters per second or something. So you guys can check it out,
Yeah.
and you can try changing the conversion factor accordingly. We'll just wait for a couple of more minutes, and when you're done with the code, you can put a yes in chat, and if you're able to get the output.
Can you show the simulation once more?
Yeah.
Yeah.
Yeah, as you can see, it's 138.3, but it is around 137.
Yeah, as you can see, even when the pointer is at a constant position, the value of the ultrasonic sensor keeps changing. That is because in real life there will be a few. It will not be exactly accurate. There will be a few inaccuracies in measurement as well. I think we'll just wait for like a couple of minutes, and then we can go ahead with the next one, or or we'll finish the next one, because the next one includes both of the previous
Yeah.
projects, and
Yeah,
then we'll
after
wait
that
out
we
there for
can.
a few minutes. Yeah.
Yep, true. Okay, the next project we can do it in this itself. Okay, you must have seen in malls and all, automatic door machines are there. Uh, when you enter, it automatically opens, and when you move away from it, it automatically closes. It sounds pretty cool, uh, and let's make it right now. This is one of the way in which we can make no, in which we can make an automatic door using a servo motor as well as distance sensor. Let's add the servo motor. Okay, and let's connect the ground pins to ground. And signal pin. Okay, to 9. Remember, it should be connected to a PWM pin, not any other pin. And the power signal, we have to connect it to the VCC or 5 volt. Yeah, we can do this, but in real life, yeah, you can use the breadboard, or you can use the breadboard here itself and do these connections. Okay, so yeah, this is the circuit. We have connected both, and the code for ultrasonic distance sensor is ready, and we need to include the code for servo motor. We'll just do that. Include. You can copy paste from the previous project, but we need to make a little changes here, which will be making servo 1. All right, and servo 1 dot attach, and it is connected to pin number 9. All right, now what we can do is, oops, yeah, I'll start the simulation again. Yeah, as you can see, the lowest value is around 4. Okay, as you can see, the lowest value is around 4 to 2 centimeter. Uh, okay, let's say the person reaches at this distance, is at this distance from the servo, from the ultrasonic sensor, then we'll open the door, or else we'll close it. If the person, okay, let's say 100. If the person at 100 distance from the servo motor, then we'll open the door, we'll open the door, and when he's far away from there, we'll close the door. All right, let's stop the simulation, and now let's write an if code. Okay, if distance is less than 100, if distance is less than 100, what we do is servo 1 dot write 90. Like in the previous case, we'll rotate it by 90 degrees, and so that the door gets opened. And yep, this should work. Else, we can make it servo 1 dot write 0. Yep. Now let's simulate and check if it's working. Then we can discuss on it. Okay, it's rotating. Okay, why is it rotating very slowly?
Yeah, but as you can see, it goes back to 0.
Yeah.
When you're above 100.
See, the distance is 132 centimeter and it is at 0th position. When we bring it below 100, yep, it starts rotating. Yeah, okay. Yeah, yeah, and it's open. And when we take it above 100 again, it goes back to 0. And you can change this distance to any of anything, and yeah, you can set it.
We'll just wait here for a couple of minutes.
Yeah.
If you guys have any
The
doubts, you
code
guys
is
can ask.
code is here. You can see this code. See the code.
As you can see, this opens up a huge range of possibilities for you. Now using Arduino, now you have a motor that can actually change. Now you can actually change the position of a physical object when the sensors receive a certain value. For example, you learned about the LDR and you learned about the servo motor now. So you can use those two so that you can open the shades of your room if your room becomes dark, and you can close the curtains when you have already light or something like that. Or you could let it turn the windows open when the room becomes hot or something using the temperature sensor. And if you guys are trying it out in the Tinkercad, put a yes in chat. Nice. So let me know when you guys finish and you guys get the right output. And then if you guys have any doubts also, you can ask. And so if you guys finish, just drop a yes in chat one again, and then we can move on.
Sir, what is the name of that servo motor?
Huh? It's called servo motor, right?
That name label.
It's called the micro servo motor. And in this circuit, it's named 1, I think.
Okay, sir.
Sanjeev, it's called SD90 server, right? Out in the market.
1 second, I'll check. I think I have it right here.
If you buy from the market, I guess one example is SD90. And
Yeah, SG90, yes. The SG90 micro servo motor. Yeah, show the code.
In my code, one error occurred that servo 1 is not declared in void setup and void loop.
Okay, I'm gonna
Sorry?
just like copy paste your code on the chat. Yeah, plus our code is available on GitHub, but if you want, you can just copy paste your code on the chat.
Okay, sir.
Did you declare servo 1 and in void setup servo 1 dot attach of the pin that you've connected it to?
Yes.
Okay, then just send the code on chat now.
Zoom is in mobile.
Okay, just check the code on GitHub and just make sure the case is right.
Yeah, and
Like,
connections also. Check.
yeah, the connections are right, and the S on servo is caps, and then the name of your servo, the object, and you're using the right. And then just make sure you're using the right, like the cases for the code as well. Then it should work. If anybody else has any doubts, you guys can put them in the chat. Wait, I'll just look at the code. Servo data. Yes, your variable name. Your trig, for second statement, int trig, you put trige, and on the void setup, you just put trig, pin mode trig dot. So you need to like make the variable names correct.
Also serial dot begin. The serial is a typo. There is a typo.
Yeah, it is SERIAL.
Cool.
Cool. Okay, I think we just wait for like a minute more. Wait for them to complete, and then we move on.
Yeah.
Just let us know if you're finished. Put a yes in chat, then we can move on. Okay, yes, cool. Is that the serial dot print ln or did you put in? Okay, just check that. And then, just send your code again, like the corrected code that you ran.
Can you send the error as well?
Just try this one. There might be.
Yeah, now works.
Okay, yeah. Yeah, it is. I think that is what they've written. Serial dot print in of distance.
I think that servo is laggy.
Showing error in.
Should
No, no. I mean,
LN, not IN, right?
yeah. Print ln, not in. Check that.
Okay, yeah. Just try checking that. I think we have to move on. Or do you just wait for more? Okay, we'll move on at 5:10. Okay, then I think we'll move on. Just try to check your code and compare it to the code that is there on GitHub. So you can just check it out. And if you still can't, if you still don't get it, you can ask in the WhatsApp group afterwards.
Where's the GitHub?
We sent you the GitHub link. Wait, I'll just send it again. There you go. Click this link. In this link, you can go to the links. There'll be a file called links. In that, I think, yeah, this will be the 2C. So you click on the 2C project, you would come across this project. 2C. Yes. And I think now we'll be moving on to the next module.
I think we should go back to slides.
Yeah, let's go back to slides.
All right. Let's okay. Also, we have done with the automatic open door. 1 second. Yeah. Let's move on to the third and final project of today. IR TV remote sensors. Okay. Yep. And yeah, we have divided into 2 parts again. First, we'll be doing IR remote, and then we'll be integrating it with LCD display. Okay, and IR sensor. The daily remotes which you use, the remote controls for TVs, for ACs, for anything. There are many remote controls at your house itself. How does they work actually? So what happens is, when we press a button on the remote, it sends out an infrared light. Infrared light is an electromagnetic wave. Before the visible light, I hope you know this part. Yeah, it sends out a infrared ray, and the TV or the AC has an IR sensor in it. What it does is the infrared light falls on the sensor, and the sensor measures the IR radiation. It is falling on it. Yeah, and yeah, the sensor measures how much light is falling and what IR, what wavelength of IR signal is falling on it, and yeah, and it is connected to the Arduino. The sensor is connected to Arduino, and using the code, will be taking the value from IR sensor and will be using it to deploy any function. For example, if you press 1 and on the TV, you will get a 1, or yeah, it does a specific function. Every button does a specific function, and yeah, the sensor sends out the signal, and it tells the sensor tells the Arduino that the user has pressed this button, and the Arduino takes the input from the sensor, and depending on that, does the specified work. All right.
Yeah. Now I'll
And
be taking.
even IR remote, we'll be using a library called IR remote.h, which we'll be using in the code explanation. This is the link, and we'll start off now.
Yeah. Thank you for that, Anish. I will be start sharing my screen. I'll just show you guys how we can use this in Tinkercad. Share screen. All right. I'll just go to Tinkercad again. There you go. Circuits. Create new circuit. Also, I'll just show Hania how you can access the, what do you call that? I'm just clicking the link on the chat, the GitHub link on the chat. So you go to a page like this. You click on links and go to the project to see, and you will get the project that you're looking for. So click on copy and tinker, and you can find the code over there. That will be the code. And yeah, now that's done. Yeah, we have the same. You can do the same for these two projects as well. They are 3A and 3B respectively. So in project 3A, what I'll essentially be doing is I'll be showing you the IR sensor for so first let me just get out our Arduino board. I'll get out the breadboard. And yeah, the next I'll show you how to get the IR sensor. So just go ahead and type IR and give a space over here. This will be the IR sensor that we will be using. Just go ahead and drop it anywhere on your on the breadboard and get the IR remote. And this is the remote that we will be using. And yeah, so as Anish explained, any remote that you may find at your house, a common remote, like be it a TV or your AC remote or something like that, they are using infrared signals because these are the most common signals. And I'll just show you the connection that we need to do for the IR sensor. The ground goes to the ground. Black, I'll make it black. The power goes to the power line. I'll make it red. And the output can go to any of the digital pins. Notice how we're using a digital pin here and not I'm just connecting it to pin 12 and not an analog input pin. So you might wonder, doesn't a digital pin only take in inputs of 0 or 1? How are we going to produce it? And we told you that each of these buttons, when you press them, will give you a unique signal. It will generate a unique signal. So that is why each of these infrared so the remote will send an infrared signal in a square wave, right? So it will be a pattern of zeros and ones, and it is essentially, this is the purpose of the IR sensor, to decode each of the signal that comes and into a number. So what we're going to be doing is we are going to be showing you how we can decode each of the buttons on this, and you can repurpose them, or you can use the button to perform a certain task. Okay, so right. So let's just get into the code. So basically, so the IR waves, as I told you, let's just go to text. These IR waves, as I told you, are come in infrared signals, and the sensor gets the input and it will convert it into a unique code. And this unique code is universal for a signal. So for example, you use a sensor over here, and you give the sensor over here, it should generate the same code as a sensor in say another country. So for that, that is why this library, there is a library called IR remote.h that somebody has created with all of these things to help us easily decode a remote. And so hence you can use, if you have the IR sensor, you can use a remote at your house to try and decoding and to try and use the remote to control something on your Arduino board. So let me just go ahead and type down, include the remote.h library, #include IR remote. So the spelling is capital I, capital R, remote, REMOTE.h. I'll repeat, #include, open angular brackets, capital R, capital I, capital R, remote.h. and then close the angular brackets. As we've seen before, whenever we create a library, whenever we introduce new libraries, we need to create objects so that we can play around with the components that we're using in the circuit. So for this particular circuit, I am going to be using I am going to be using an object called. So we are going to be creating two objects here. This is called the IR. So the first function is IR receive. That is basically IR receive. So we're just going to create an object that receives the signal from the IR sensor, and we're gonna receives the value from the IR signal from the IR sensor, and we're gonna the argument of the function is going to be in parentheses is going to be the pin that is connected to in the Arduino. Over here we've connected to pin 12, so I'll just go ahead and put this there 12. And the next, as I told you, this IR sensor decodes the signal into a number, right? So we need somewhere for those results to be stored. So for that, we're going to create another object called using the function decode DECODE, all lowercase, underscore RESULTS results, and space. I'm going to name the object results because that is quite intuitive. Results. And now in the void setup, we need to, okay, so here, as I've told you, as we've done for the past few projects, we need to figure out what the value of results is, right, for each signal that we send. So for that, we are going to use the serial monitor again. So let me just go ahead and initialize it, and we won't need needing this statement in mode 13. So we're just going to be using serial dot begin baud rate of, oh my bad, a baud rate of 9600 or 9600, and then we have to tell the Arduino that we're going to be using an IR sensor. So we're just going to enable the IR sensor, receive dot, you are going to use the object receive dot enable IR capital IM. So now this function tells the sensor to be on the lookout. It enables the sensor to be on the lookout for any IR signals that it might receive. And now let's go into the void loop statement. Let's just get rid of this. And over here, all right. So we don't need to be printing every time all the time, because we don't know if there will be a signal or not. So we only need to print whenever the sensor receives a signal. So for that, the code over here is we're using an if statement. If receive, because that is the object that we have defined for the sensor, receive dot decode of ampersand results. So what this basically does is this statement will only be true whenever the IR sensor receives an IR signal. So if there's no signal, the statement will be false, and none of the statements will get executed. So I'll just open another curly braces for a block of code. And over here, if I get the signal, so if I ever receive a signal, I want to print it, right? So I'm just going to type in serial dot print ln and then results. So we want to print the results, right? So we're just going to write results. That's the object for the results dot value. So what it is essentially checking for here is that if results have a value, which means it has received the code and it has been decoded, then we're going to run the statement. And then if we're running the statement, we're going to print out the results. And once we do this, next we're just going to tell the receiver to start receiving again. So receive dot resume. All right. And I'll just close this if statement. And now we should be able to look at our code. All right, start simulation. All right, for this project, I'm just going to introduce you to like a few of the codes. For example, I just click once. As you can see, it prints out a unique code. I'll press 1 again. As you can see, I get the same unique code, which means this remote generates a unique signal every time I press 1. Now I'm going to go click 2 again. I'm going to click 2 for the first time. As you can see, I click 2, I get a function, and then I get a junk value because I pressed 2 for a long time. That means that's a receiver. That is a repeater signal that we will not need for this program. Now I'll go ahead and press 3 once. As you can see, pressing 3 once generates a different unique code, and I'll press it again. I'll generate the same code. So let me just clear it again, and I'll show you that we'll get the same code if I press them again all at once. I mean, press them again once again. So I'll press 1. As you can see, you get a unique code 1658290 I'll press 2. You get a unique code for 2, that is 166155543, and then I'll press 3. As you can see, you get 16559923223. All right, I'll stop the simulation now, and I'll wait for like a couple of minutes here if you guys have any doubts. If you guys have any doubts in understanding how this happens. And yeah, if you're trying out this project, just type an yes in the chat box. Nice. And okay, so I'll just explain to you what we're planning to do with this, right? So now we have the remote, and we can receive a signal from the remote, and we know how to decode the signal for each button. So now we can repurpose this button such that if this button is being pressed, I want to do something. So for that, all right, yes. So basically what there is usually these decodings, they print it in something called the hex value. So the hex value of each remote would be different, but not all remotes will have unique sensors. For example, there'll be a range of values for a manufacturer. If you take Sony, for example, almost all Sony products will come into that range. You take Sanyo or Panasonic. So then there is a library in which you can also cross check. I think there's another library in which you can cross check what type of remote your remote is. Like if from the signal that your remote sends, it will tell you what company signal it is. So basically, yes, in a remote, all buttons will have a unique signal. But sometimes you might have different manufacturers having the same signal for a particular key. So that's why you might have noticed that some of your remotes might be able to control another device that it is not meant to control. That is essentially because all it is doing is sending the same IR signal that the receiver is expecting to receive. And another cool thing is that since this is infrared, you will not be able to see it, but you will not be able to see the signals. But if you want to look at it, some of your phone cameras, they might have they might have their IR filters enabled. So if you somehow disable them, or if your phone camera does not have the IR signal disabled, you can just point them at the IR sensor transmitter on your remote, IR transmitter on your remote, and you can just point it at that, and you can try pressing a button, and when you look at it through your camera, you can see a purple color button, a purple color light. I just thought this is a cool experiment that you can try out if your camera does not have an IR filter. No, you cannot change the unique signal for private use. For that, I think you need to go look into how the signals are produced and how the remote works. That you cannot do using these the components that we have, unless you try opening the remote up and somehow figure out how, like, because you will probably have a board PCB or something programmed in that, so you'll probably have to change that. But if you have a random remote and you have a receiver, then you can program the existing signals that the remote produces to do something cool. All right. So for example, over here, I can try to do something boring. Like I'll try. Okay, wait. I can try just printing. If I get this code, I'll print 1. If I get this code, I'll print 2. I wanted to try something else. So I'll try to, whenever we press the button 1, we will light up 1 LED. And whenever we do, if we don't do that, then we'll turn it off. So I'll just try doing that. Okay, or actually, okay, so I think we're running out of time. So we'll move on to the next project, that is using this to instead of an LED, we'll just use a we'll just use an LCD display instead to give you, because that seems a little more complex than that and a little more interesting. So I'll just move on to that project because I feel like we're running out of time. So this is the project to be, and just go ahead and put it in the chat if you're done with it. And if you guys have any doubts, else let's just move on. All right. I'll wait for like a minute more. Okay, cool. So then I'll start. Okay. Okay, then we'll just wait for a minute more and then we'll do it. And then we'll move. By the time I can try showing you the unique code of the other buttons. 4, 5, 6, 7, 8, 9, 0, down, power, volume, function. So as you can see, they all produce unique signals. I'll just go ahead and stop the simulation. I'll clear this. Okay, yeah. You can just try it. If it doesn't work out, you can always look at the GitHub link. And if you still have some more doubts, you can ask it after the you can ask it on the WhatsApp group. All right. Now let me just move on. So I'll just go ahead and create a new circuit. Create new circuit. Right. Now I'll just get the LCD out because we're going to be using it with the LCD display. That should be about right. All right. Now I'll just go ahead and get my IR sensors out. Get the IR sensor, drop it over here. Get the remote, keep it here, I guess. All right. So now, yeah. So let's just go ahead and put the out power to power, ground to ground. That is power, and then that's the output. Power to power. Okay, ground was here. All right. Pin 8. Black and red. All right. Now let's just look at the code again. It already has the LCD, etc. As the begin. Yep. So yeah, we don't need the statement. I'll just remove it. All right. Let's see that begin. Okay, so now let's just go ahead and create our objects. I'll just go ahead and type hash include ir dot h, ir remote dot h. All right, we have the liquid crystal dot h. Then let's just go ahead and type in our receiver, that is IRRECV equals space receive of pin number. What pin have we used here? Pin number 8. Okay, cool. Now let us go ahead and declare an object for results. Decode results. Now we've created both our objects that we need. Cool. Right. Now we will go ahead and enable our IR remote. Just gonna receive dot enable receive dot enable IR IN. So this will enable the receiver to start receiving signals, and we're going to be using serial monitor. So I'll just go ahead and type serial.begin 9600. Cool. All right, now let's just go ahead to our while loop, and yep, initially let us print LCD.clear. All right, or we can just strike, or we can just clear the LCD in setup. Cool. So this will just clear the LCD every time we start it. And then now let's just go ahead and print. Let's just go ahead and get our value now. We're going to be printing only if IR, only if the IR sensor receives a value. So we're just going to be typing receive IR receive dot decode ampersand results. So this is going to check if every time this statement is going to be true only if we just did it moments ago, only if the sensor receives a signal. And let's just go ahead and print. This is printed on the serial monitor because we'll just note down all the values that we're going to do it for. Serial.print ln results dot value. All right, and now let's just receive again, receive dot resume. Cool. And once we're done with this, I'll just close this if statement, and we don't need these two lines. Right. So now I'm just going to start running this code. Okay, so I'll just so I'm just going to program this for first three numbers, and you can extrapolate it to the other numbers, right? So why isn't this working? So it's receive.resume. 1 second, let me just check this code again. If receive.decode, and I have set up, yes, IR receive at 8, output pin, ground power. All right. Okay, so the power, the ground is connected to the, oh, okay, my bad. The ground should be connected to the ground. All right. And now let me try running the simulation. Okay. So as you can see, the LCD is begun, but I'll just try to, as you can see, I'm just going to do it for 1, and then for 2, and then for 3. So now we have the values, that the unique codes for each of these signals. So now we're going to be using this to print out the value, to print out 1 on the LCD screen if we receive a 1, if we to print out 2 if we receive 2, and etc. So let us move on. So inside this if loop, so we want to do this only if we have received a signal from the IR remote sensor. So I am just going to go ahead and LCD. We'll set it. LCD dot set cursor C caps set cursor at 0,1. This means that it is going to set the cursor at the first column of the second row, and And yeah, so now we can start printing. We'll take an if statement if results dot value equal to what is the value of 1 over here? 165. What is the unique code for 1? 165.82903. All right. 903. So if we get this code, we want to print. We want LCD to print LCD dot print 1. All right. And then let's look at else if results dot value equal to 166.155.43. Let's go ahead and print LCD dot print 2 with an exclamation mark, because why not? And then let's go to else if, yeah, let's just go to else. Let me just get the alignment right. Else if results dot value equal to 165.99.2233 9923. We need to print LCD dot print 3. All right. So now that we're done with this, let us check if our code is working. All right. As you can see, when we press 1, the serial monitor prints the value 1, the unique code, and the LCD prints the code 1. And now let us look. Let's press 2. As you can see, LCD gives a 2 with an exclamation mark. And yes, and when I press 3, it gives me a 3. All right. When I press a different value, I just get the code, and the value doesn't change. And yeah, that's the circuit. And if you have any doubt, you can ask me. Until then, I'll be trying. If you have any doubt, you can ask. You can put it in the chat, and I'll just leave this code for some time. And if you guys want me to, I will try to extend this to say 5 or 6 more numbers. Okay, yes. And also, if we're done with this and we still have some time left, I will also show you something called the switch case statement, which is just like an if-else statement, but it's just used for this specific case of where we have to compare one variable with a bunch of values. So if you're done with this, just put a yes in chat, and then we can move on. With that, we will have come to the end of our session. I mean, you can take a look at the code and you can try it again.
Yeah, we can agree with that. It's little complicated. I mean, there are many functions and using, but the concept is simple.
Yeah,
Right.
so yeah, we can agree that because we might just be beginning with the code. So, but yeah, so the concept is essentially very simple, right? So what we're doing is we explain to you how the the IR sensor receives signals how a remote gives all unique signals to the IR sensor, and the IR sensor, if it receives it, will decode it and give you a universal code for that signal. And so what we're doing is we're just using the serial monitor to get the universal code for each of the buttons on the remote, and we're using the same code to compare, to check if the button is being pressed again. And if the button is being pressed, we want to do something. We want to assign that button to a specific task. Over here, we're just giving it a simple task that is printing 1 on the LCD display. But you can try doing something like, you can try clubbing. Say if you give 1, then rotate the servo motor by 10 degrees. For 2, rotate it by 20 degrees. So now you have a lot of project options with all the things. So you guys can, the recording I think will be available on YouTube. I'm not so sure. And if that is so, then you guys can rewatch the lecture and try to understand the code. Because I think once you understand the first LCD project that we did, and then you understand the first IR remote project that I did just before, like a moments ago, then you could easily understand this project.
Yeah, you can also do a project like when you press 1, red LED glows. When you press 2, blue LED glows. Something like that. You can use your creativity and explore on many projects.
Our whole objective of this session is to give you an idea of what Arduino is and what the interface can do. And if you have the kit, it basically the point that we want to put across is, you can, once you understand how a sensor or an actuator works, you can basically use your creativity to come up with projects and solve your real life problems at home. Say, for example, and you can just, and at the end of the day, once you know how Arduino works and how you can learn how each sensor works, the idea for the project is limitless, and it is only bound by your creativity. Yes,
Yeah.
exactly. I'll
I
just
guess
leave
you
this
can
for a few minutes.
explain switch case.
All right now. Okay, yeah. Okay, we'll explain switch case and then we'll finish it up.
Yeah.
All right. Okay, yeah. I'll show you the code base. Okay, so basically, okay, yeah. So I'll just I'll remove all the unnecessary comments. Now I think the whole code should be visible in the screen only. Yes. This is the whole code. If you find it hard typing every time this whole huge number, you can create another variable called 1 using a preferred data type. I would say, because this number is huge, you should use a long int or a double, I think. So if you use those data types, you can store this value, and you can, instead of typing this whole huge number down every time you want to access the signal, you can just use the variable. And people who are trying to do it also can put a yes in chat.
Yeah, you can also use GitHub, open GitHub and copy the code.
Yes, we have this code written on GitHub. On GitHub, we have the, okay, yeah. So let me just explain switch case, and then you can also understand the other code on GitHub where we've initialized all 0 to 9. All right. So basically, what we're doing here is we're using the if-else statement, right? For comparing different values with the same variable. Here, the variable that we're using is results.value. Every time we write if results.value equal to this, if results for accurate this, do this. If this is not, if this, do this. But we don't. But right now, we'll show you what to do. We'll show you another conditional statement that is designed specifically for this use case. That is, you have to compare one variable with multiple different values it can take, right? So I'll just show you the syntax, and I think it would be pretty easy. Wait, I'll just show you the syntax. Serial monitor, hopefully. All right, let me just clear the serial monitor. Okay, let me just keep these codes over here. I'll just copy this and copy, and I'll type it here as a comment. One, that. Copy 2 equals that, and 3 equals that. All right. So now I'll just remove these statements and I'll show you what you can replace it with. All right. So basically the syntax for this is called switch. So you're using the keyword switch. And in the bracket of switch, you're supposed to give the variable that you want to compare. So over here, the variable that we're comparing is results.value. So we want to compare, and let's just go ahead, open. Let's just go ahead and type. And each of the cases are called cases. I mean, wait, I'll just show you. There you go. Switch case. I'll open the parentheses, and then for each case, the keyword is case. So I type in case and 1, right? So the value of 1 is k. After the case word, you're supposed to write the value of the variable you're checking for. So over here, I'm checking for 1, whose value is this weird huge number, whose code is this huge number. And if it is this, go ahead, put a colon, and then open another block, because if this is true, then this block will get executed. Over here, we have to print LCD dot print 1. Cool. All right. So then let's just go ahead and delay for 1,000 seconds, because we just want to know if it is a 1 or not. I'll just go ahead and remove this clear. We want to clear it after a second. So we just want 1 to be printed for a second. And then after that, we will clear the LCD. All right. Now, once we've done this, let's go ahead and break. So I'll explain what the break statement is right now. So basically, what the break statement is it if the code comes across a break statement, then it will move out of its smallest loop, of its existing loop. So if the switch case comes across the break statement, then the switch case, the whole switch case loop will stop, and then it will go to the next statement after the switch case, that is receive.resume. Let me just show you with a few more examples, just a second. And the next case is we want to check for 2. There you go. And 2, we'll open the braces, LCD.print 2 with an exclamation mark. All right, then I want to delay 1,000 milliseconds, that is 1 second. And after that, I want the LCD screen to be clear, LCD.clear. Cool. And then I want to break again. I'll tell you in a minute why we're introducing this break statement. And then the last one is case of 3. Just copy that. Oh, damn. My bad. All right, I'll just go back. Case and 3. Cool. And then I want print LCD.print 3, and I want to delay 1000. That is 1 second. After that, I want the LCD to be cleared. So LCD dot clear, and then break. Right.
I think you have to remove
yes,
curly
yes, yes,
braces.
I'll just put the curly braces. Okay. And yeah, this program should work. Oh, okay, my bad. So I should have closed one more curly braces for the switch case. The switch case has a curly braces. Why can't I type? Okay. Oh my God. Okay. This one has encountered a problem. The Tinkercad is stuck. So I'll just copy the code again.
It auto saves. Go back and join. Use it again.
All right. This one, right? Yeah. Okay. Tinkercad started glitching. So let me just try it again. The code. Yes. Okay. Yeah. So here we just need to add another curly braces. Now the code should work. All right. As you can see, the LED is turned on. Let's just go ahead. As you can see, you get a 1 and it disappears after a second. I press a 2 and it disappears after a second. I get a 3 and it disappears after a second. So now let me explain the use of the break statement. So in the switch case, we're basically comparing different cases of values for the same variable. So what happens is in switch case, if this variable, if this statement is true, and then it would execute this code, and it will also execute the 2 code, and it'll also execute the 3 code. We don't want that, right? We don't want that, right? So that is why we use the statement break. So every time we get a 1, we just want to move out. We don't want to print 2 and 3 as well. So that's exactly why we use a break statement. So this is called a control statement. So it'll exit the loop. So it'll exit the switch loop. It'll exit the switch case. It'll exit this curly braces given here, and it'll take us to receive.resume. Yeah, so I'll just leave this code over here for a while. If you guys have any doubts. Yeah. Yeah, we understand that. So you need to start debugging. So first, if I were you, then I'd start debugging by checking if all my connections are right and if all the ports are right, and then I will go ahead and checking if my if all the commands are given the same correct case and the type, and if I have any typos in my code. And after that, I'll just go ahead and check if my loop is right. So like, say for example, I get the results, I get the value of 1, and then I'll go here and I'll check if it works, and then I'll check if all my code is right, and then because it is not doing what it is supposed to, right? So just go ahead and try running through your loop on your mind and try to figure out the error. And if not, you can always try to go to the GitHub link, find the code and compare your code and find out the error. Yeah, we understand that the last couple of projects must be a little harder for you to understand. So my only suggestion would be to keep trying out these projects at home and like try out how to understand the input, how the IR remote works, and keep trying out from the basic project. And yeah, I think that's our time. And if you have any doubts, you can ask, or else we can conclude our session. You can always look it up on GitHub. We have all the links to all the projects. Yes, so just check if your curly braces are correctly closed. So for switch case, I'm closing it over here. I'll just put it
Can
in a
you
different
send the
plan.
GitHub link again?
All right. I would suggest that you bookmark the GitHub link and keep it on your browser. I'll just send it to you 1 second. I'll just stop presenting for a minute. There you go, I've shared it. Nice. So yeah. So yeah, that's it. This will be this. Yeah, I'm just gonna run through our slides. So yeah, we have the code, we have the link, and then yeah. So we feel that we hope that once you have done with all of this, and you are feeling slightly more confident with yourself and your ability to use Arduino. So hopefully this meme resonates with you. Yeah, thank you for attending. Hopefully you attend our session tomorrow, in which we'll be covering slightly more advanced topics. So thank you for attending from on behalf of Electronics Club.
Yeah, thanks a lot for attending. Keep up the N2 tomorrow as well.
Thank you, Sanjeev and Anish, for conducting this lively session. So I guess compared to day one, like many of you got upgraded from code blocks to using direct C code. So I guess that transition was easy for you, and Anish and Sanjeev explained it pretty well, like explaining it from the basics to doing it to helping you debug the code or solving out if there are any minor issues as well. So thank you all for participating, and thank you Sanjeev and Anish again for being
Thanks, Adit.
so much helpful.
Yeah, thank you for the opportunity, and hope to see you guys tomorrow.
Thank you guys. So we'll see you all on day 3. So thank you everyone. Bye bye.
Yeah, bye bye.
Yeah, bye.